Hi class, today we're going to go through those three-dimensional isometric drawings step by step. But before we start going into those steps, let's review some of the geometry words that I'm going to be using to describe some of our drawings. So the first one is what I use to describe part of the coordinate system that starts right there, that 0, 0 position. I will sometimes call that the origin. So the origin is just that xy position of 0, 0 on our coordinate system. Sometimes I will say a line is horizontal or lying down. And you can think of that word horizon because you can think of it as the setting sun on the horizon. Another word I might use is vertical. And when I think of the word vertical, I think of the word vertebrae. And vertebrae is just another word for your spine. Okay, so when I think of vertical, it's standing up like your spine. When we start to draw multiple lines, we might notice that two lines that never touch, like these two, are called parallel. Whereas two lines that intersect at a right angle is called perpendicular. And that right angle is a 90-degree angle. And then in 3 dimensions, in addition to something being perpendicular, I might say that it's orthogonal because it's actually perpendicular to multiple axes. Like our z-axis would be perpendicular to both x and y. And so I'm going to call that orthogonal. Okay, so try it yourself. See if you can match all these lines with one of those words that we just said. Okay, so now when I talk about trying to represent a 3D model in 2 dimensions, I might often call that 2-dimensional drawing a sketch. And then the process of making that 3D object into a representation, a 2D representation of it, is called a projection. Kind of like if I was shining a light on an object and projecting it against a wall, that wall would be flat. And so that flat projection showing one of the faces is what we've already been talking about, which is the orthographic view. Okay, and this is review. If you have your reference cube, or if you have Onshape, you can line it up to look like our top, our front, and our right. and we can see if we can define all of these planes. Okay, so when we switch to top view, we have the X and the Y. So that's our XY plane. When we have our front view, that is our XZ plane. And I can also look by looking at this picture over here. My front is right here, and so this is X and that is Z along my front. And then the last one is my right view. So my right view is orthogonal to the X plane, so it's actually going to have the Y plane and the Z plane. Okay, and when I check on shape or I check my reference box, that's exactly what I see, my Y and my Z, or my right plane. Okay, so this is the time for us to stop and see if we can identify all of these planes. And you can either do it by looking at this picture, or you can go into Onshape and try all 7 of these shortcut keys. Okay, so it happens that the front is our first shortcut, and it's followed by the back. The left is our next one. It's followed by the right. The top is next, and it's followed by the bottom. But the interesting thing is, now let's put in all the X, Z. It's basically the back side of the front, so I would expect that to be a reflection on the back side. I know from what I see on the cube that my right is YZ, so I expect my left to be a reflection of that, which is Y and Z. And then I can see from my cube here as well that my top is my X and my Y. And so my bottom is going to be the reflection of that, but it just turns out that the X is at the top. And that's actually the only place where my horizontal axis runs along the top, which is my second question. That's the bottom face. And then for everything else, or for my 3 faces that I use the most often, my top, my front, and my right, all 3 of those have the origin at the bottom left. Okay, now we are ready to start talking about drawing. And this is important because for us to draw, we do need to figure out what face are we drawing and what is the axis that we're drawing it along. So the first part of what we have to draw is the fact that we take a square-ish or rectangular-ish object, but we're not drawing squares when we get it into the isometric view. So the effect of the shape has a different name for it. It's called shearing. And shearing is when I take something that is square like this, but I apply some force to it, and it actually tilts it or transforms it into a parallelogram instead of a rectangle. And it comes from the fact that a shear is like a pair of scissors. And when you shear wool off of a sheep, or when you cut hair, it does actually produce a little bit of a force so that you are deforming the whatever it is that you're cutting. But I don't really use that word shear as I draw. What I do is I'll say that we're projecting this rectangle onto a surface that now makes it look like a parallelogram instead. The other word I'm going to use is extrude. And extrude means that I start with some two-dimensional form. In this case right here, it's a rectangle. And I'm going to move it along an orthogonal axis. Okay, so extruding it along this direction is actually going to make it into a rectangular prism. And we think of something flat as two-dimensional, so this thing has a, in this case, a height and a width, but this third dimension is giving it depth. Okay, so that third dimension will always be orthogonal to my sketch plane where my two-dimensional shape is drawn. So let's practice that. Okay, I didn't really specify what my drawing plane is, so let's just pick one. I have a T that I'm going to draw, and let's say I want that on the, let's do the top plane. I look up in my notes and I notice that the top plane is XY, so I'm going to just draw my reference X and Y. And let's see why I drew it like that. I didn't draw it like this. This is how you do it in math, right? You have an X and a Y. I drew it like this because when I go over and look at my reference, there's my X and there's my Y. Okay, so I need to draw it in this isometric form. And that's going to help me because when I project my T onto my top plane, my lines need to be parallel to these axes. So there's the top of my T, there's the side of my T, okay, so let me redraw this XY because on here it is X and Y, but over here X became this way and Y became that way. So we're still drawing the shape along XY, it just looks different now that it's an isometric. Okay, the next step is extruding, and our extrusion has to be orthogonal to our sketch plane. So since our sketch plane is XY, our extrusion is going to be along the Z-axis. Okay, but the Z-axis goes up in the positive, and since we're on the top, we're going to extrude down. So I'm just going to recopy my top face, and then I'm going to show you that the extrusions have to go okay. So the next thing we're going to identify is the extrude axes. So since our sketch plane was on the XY, I need the axes that's orthogonal to XY, which is going to be Z. And so Z positive is going up, but I have a top face, so let's just redraw our top face. Our extrude needs to be parallel to this Z-axis, but our top face needs the extrusion to go down. And then we'll connect our shape. Okay, this can be broken down into 4 steps that we can repeat for any sketch that we draw. Okay, and those 4 steps are going to be: identify the sketch plane, project or shear your shape parallel to the reference axis, extrude the corners orthogonal to the sketch plane, and then connect the dots of your extrusion to shadow your shape. Okay, we're going to practice that. So we said our first step is identify the sketch plane. On our top plane, our top face, our axis is X, Y. So for me to sketch this shape, I need to be parallel to X and parallel to Y. Okay, because this was X and this was Y. My third step is to extrude, and since it's the top face, I'm going to extrude down. So let's see what that looks like with this top face repeated. I'm going to extrude down. And then our last step, I'm going to cheat a little bit. Just going to copy that and paste it. Our last step is just to create that shadow by connecting our extrude lines. Okay, let's see if we can repeat it for the front face. The steps are: identify the plane. So for the front, we have X and Z. So that's going to look like C and X. Okay, so I need to take my Z and draw it parallel to X and parallel to Z. Then this is a front face, so extrusion is along the extrusion goes back, which would be along the y-axis. Okay, so if I copy my front face, then my extrusion should all go along the y-axis. Let's copy that again. And the last step is to connect the back of our Z. Okay, let's try it one more time with the right face. So our right face means that this is Y and this is Z, and YZ is drawn YZ. So now I need to draw my F. Okay, so my orthogonal line would be my x-axis. So all of my extrusions are going to be along that x-axis. Okay, and in a separate video, I'm going to draw each one of these in isometric paper.